network faster, right? Hello, and welcome to another AP Daily video for AP Computer Science Principles. Today's topic is fault tolerance. My name is Mrs. Julia Alano, and I teach at Hamilton Southeastern High School in Fishers, Indiana. In this video, we will evaluate different networks to identify vulnerabilities and to determine the benefits of fault tolerance. So what exactly will we learn today? Let's take a look. So the learning objective is for fault-tolerant systems like the internet. So yes, we're going to learn about the internet and describe the benefits of fault tolerance as well as identify vulnerabilities. Here are our essential knowledge statements. You notice that we're also going to talk about redundancy in a network and how that can make our network stronger. Here are some more essential knowledge statements talking about failures in the system and how we can make it stronger, and more about redundancy. So let's take a look at an example. The letters on the right represent computing devices. The lines below are wires to connect those devices. I'll demonstrate and show you a network similar to the one here, which isn't really a network because we haven't connected anything yet. But if we had these 7 devices and these 6 wires, could we connect them all so they could all communicate? Would we be able to make a network that works just so they can all communicate? So using this 6 wires, we could start connecting A to B, B to C, and we're working on a network. So let's take a look. Could we create that network? Here it is. This network will connect each device. They'll each be able to talk to each one. It may be a pretty long path because A will have to go to B, to C, to D, to get all the way to G. So it is a network where they can all communicate. But what if we want to communicate directly with each device on the network? How about this network? This network allows every device to communicate directly with every other device on the network, which should make our network faster, right? So which one's better? That's a bunch of wires. What's the benefit? What are the benefits of each of these networks that we've seen? In this network, the benefit is that it doesn't take very many resources. But what happens if one of the paths goes down, as you can see here? Now A, B, C, and D are completely cut off from E, F, and G. So in this network, while it doesn't use very many resources, it doesn't allow for us to, if something goes wrong, it doesn't allow for the failure really causes a major problem. So let's look at our other network with lots of wires. So this network is redundant because there is more than one path from each of the devices to each of the other devices. You can go directly or you can go through the other devices. And so in this case, if one of the paths goes down, the devices can still communicate. This network is fault tolerant. So even though the wire goes down at G, you can still get from G to all the other devices on this network, even though there are 4 wires that go down, because oftentimes when one thing goes down in a network, other things go down as well. So it's very important to have redundancy in your network. So let's practice some questions here. You decide, is this network fault tolerant? So we want to determine, are we able to get from each device to another device, even if something goes down? So if you want to pause the video and think about it, you can, but basically you want to try to trace a path from each of the devices to each of the other devices and make sure there is more than one path available. So let's take a look. So here are some of the paths I traced from A to each of the other letters. So as you can see, I was able to find 2 paths from A to B, 2 paths from A to C, and so forth. So each one of these devices, there is another path to each of the other devices, and there are at least 2 paths to each of the other devices. So this network is fault tolerant because you are able, even if one path goes down, you could still communicate with all the other devices on the network. Let's take a look at another one. Is this network fault tolerant? Again, make sure you check to see if each device can clearly communicate with each other device, even if one path goes down. If you want to pause the video and think about it, this would be a good time, because here's part of the solution. In tracing from A, you see that we can get from A to each of the other devices in two different ways. But if you really look at the network, because we can't just look at one device, we need to look at every device. Each device is important. So if we look at the entire network, and you can kind of see quickly by just checking each of the letters. If we look at A, you notice there are 2 wires. B, there will be 2 wires leaving. C has 3, D has 2, E has 2, but F only has 1 wire. So while all the paths from A worked to, there were 2 paths from A to each of the other letters, there is only 1 path to F. So if this path goes down, F will be cut off. So this network is not fault tolerant. So just checking one letter, not maybe the best way, but checking to make sure and looking at each of the devices to make sure it has a path to each, has more than one path leaving it. Let's take a look at another example. Is this network fault tolerant? Again, if you'd like to pause the video, now's your chance to make sure you think you have the right answer. So here are some of the paths I did. So here I was able to find 2 paths, but in my tracing, you should see every single one of my paths starts with AG. And then when I get to the end, there's only 1 path to get from A to G, and I use that same path all the time. So again, this network is not fault tolerant, because that path from A to G, if it goes down, again, A is cut off and there's no longer any communication to it. So this network is not fault tolerant. So what should we take away? Again, the internet is a fault tolerant system. So we were able to see the benefits of fault tolerance and the vulnerabilities of failure in a system today. So here are some of the essential knowledge statements that talk about redundancy as well. And we saw how the internet is a redundant network with many wires connecting devices, which makes it fault tolerant. So redundancy, again, is what helps our internet become reliable and able to scale to more devices and more people. That is it for today. Thank you very much. Have a great day.